Good morning and good afternoon. My name is Norman Clark. I'm a field applications engineer at Electro Industries, and today I will be providing a general overview of the Shark 250 meter using the Combi software. Things that we'll be discussing during this webinar will be communications and polling screens. Note, I will also be connecting to a Shark 250 meter in our lab and discussing the individual topics. I will probably be going back and forth between the slides and the communicator, so hopefully it won't be much of an interruption. So there are 6 ways of communicating with the Shark 250 meter. The first one is the USB on the front panel. The second is the 10/100 Ethernet, which is the optional board that you can purchase. It's the INP 100S card. And the third is the RS-45 on the rear of the meter. So when you first connect to the meter with the USB 485 connection, I should say the USB to USB connection, you will need to purchase a USB cable, which is the USB mini B plug. We call it the USB type A to type USB mini B plug part number CAB 26522, which you can purchase online at electroind.com/shop. And so once the USB A to USB mini cable is connected, you will also need to have a computer and a laptop computer connected from the USB port to the mini USB port on the front panel of the Shark 250. And once you make that connection to both, you will then be issued a COM port, and this can be observed through the device manager in the Windows screen. So the next option is the Shark 250 Ethernet connection. This is basically a laptop computer. You'll need USB to Ethernet converter and a Ethernet patch cable. And of course, the Ethernet option allows you to have 12 Modbus simultaneous connections, TCP connections to the meter. And the default IP address for the Shark 250 is 10.0.0.2. And this is a demonstration of the Ethernet cable connection to the rear of the meter, the Shark 250 meter. Next, we have the Shark 250 RS-485 connection. And this comes with a built-in RS-485 port to the rear of the meter, as we took a peek earlier. You'll need a USB to 485 cable to connect to this meter. Typically, you can purchase this online from electroind.com, products, and so on. And this is a 6-foot cable. Again, you can purchase this online. You'll also need an additional driver, USB to RS-485 driver. Also note, going back to what I said previously, the USB to USB connection with the mini plug does not require a driver. A Windows driver is sufficient to get you started. With the USB to 485 driver connection, you will need to download that from the ElectroIND website. So the USB cable is a 3-conductor cable, and it's connected as follows. You have the orange, which is a plus connection. So when you look at the wiring, you'll see orange, yellow, and black, and that's the side that will be connecting to the meter. Again, the orange is a black connection, the yellow is a minus, and black is the shield. And this is what it would look like after you've made your connection to the back of the meter on the 485 port. And this is the cable that you would purchase online. The USB 485 connection is also connected to your computer end, and a port will be assigned once you make the connection. So again, if you look at your device manager, you'll see COM port assigned for that USB 485 cable connection. In this case, it's COM port 8. We basically got the preliminary information on getting started with the communications. So now we would need the software. And this entails going to the website and downloading the free software. And the link is electroind.com/downloads/software downloads. And once you have that software in place, you do the install, you're pretty much ready to go and connect to a meter and start doing your programming, viewing, and so on. And so in this particular case, we've gone through the USB, mini USB connection, the USB to RS-485, and Ethernet. And I personally prefer to go to Ethernet because it's the simplest setup. When you do this, choose this option, that's assuming that you have the Ethernet card purchased. You will need to set up your laptop computer to make sure it has the same address as the meter. Note the meter does default to IPX 10.0.0.2, subnet mask 255.255.255.0 Class C address, and you would have to set up something similar to your machine on your laptop computer, which would be on the same network, except the host address at the end would be anything other than .2. So let's launch Communicator. So I'm going to jump out. Let's take a look at what the Communicator will look like once we connect to it. So we'll click on the connect button, and we'll notice a pop-up screen that has serial and Ethernet. In this case, we're going to choose to do the Ethernet, or network connection, I should say. If we chose the serial connection, we would have used one of the USB connections that we talked about before, which is USB to USB, or USB to 485. Again, in this case, I prefer to use the Ethernet option or network option and connect to the meter. So this type of connection, you will need, again, the address of the meter, which is defaults at 10.0.0.2, and that would go into the host field. The network port number remains the same. That's a default Modbus TCP port number, 502. And note this is a Modbus meter, so naturally 502 is the port number. The Modbus TCP option would be chosen, and you're pretty much ready to go. The meter that we'll be talking with in our lab is a 172.20.167.187 address. So when you first connect to the meter, you see the device status box. And in that window, you will be able to see the device name, the meter name, device type, it's a Shark 250, the serial number. And in the other half of the screen, you'll see the firmware version, that is the boot, firmware version 1 in this case, run version 2, ASIC version 3, state. V-switch is very important. We'll touch on that briefly as we go further in. The assembly late, date of manufacture, and temperature, and what other option boards are installed. So we know the network card was one of the option boards we talked about. And then there's also in this meter a KYZ board, which is option 2. And we'll talk about those as we go further along. The first part of this connection is, I think we're going to talk about the V-switch. So we'll go to the tools screen and the V-switch. The V-switch is basically gives you the option of installing certain keys that allows us to upgrade meter memory, additional memory for the extensive data logging, which we'll talk about a little bit earlier. The option V-switch keys are the range from V2 to V4, And so this also gives you ability to look at trending, additional trending, limit alarms, IO changes, and other things such as waveforms. Um, uh, I think pretty much that's as far as the limitations of what we have. So what you would do is you would click on that box, and assuming that you contacted somebody from Electro Industries support or anyone in sales, they can help you get this started. So they would basically assign you once the order is placed for the vSwitch upgrade, you would be issued a key, a special key, and you would enter that into this field and click update, and that would allow you to get to the version of the vSwitch version, which again could be anyone from V2 to V4 for the Shark to 50, and that would allow you to see some of the options that you wanted. And that concludes Module 1, which basically talks about connecting to the meter and the switch option. So connecting to the meter, once we're here, we've connected to the meter, we have a few menu choices to pull down from. I won't go into everything on day one, all the menus, but I'll touch on a few things like the real-time polling, which is very important. We'll also talk about tools, which will give us real-time, I should say, the programming information. And those are the basic things that we'll talk about today. So let's get started. So I'll look at the real-time poll, and we'll look at the real-time readings. So the real-time readings, we'll move over to instantaneous polling. So instantaneous polling, what you see are the real-time, the meters updating, as you can see, instantaneously on what we call real-time. And what you can see is the voltage on the left side, VAN, VBN, VCN, all voltage A to neutral, B to neutral, C to neutral, phase-to-phase voltage, A to B, B to C, C to A, and your instantaneous currents, IA, IB, IC, and the neutral current. So you can see there's some imbalances here that we're seeing some current flowing on the neutral, but this is very normal in a lot of cases. So in the other column here, we see a max min values. Real power is demonstrated in the center of the screen, where you can see real-time megawatts in this case, because it's 4,141 K or 4.1 megawatt, and that would be the instantaneous demand value that you're seeing at that time. You also see average values and min and max values in the real power screen. Additional to that, on the screen you see real power VARs, and again this is 1 second average and min max values, and it's updating as we speak. The next column or window is the apparent power, and we can see all of that. With all this information, you have enough to determine power factor, but it's not, although it's not displayed here, we could see that in other windows. You also have drop downs, voltage A, B, and C, I, A, B, and C, and as you can see, it changes colors to represent each measurement for voltage, or I should say each quantity for volts and amps. So we'll close this out, and we'll take a look at the next screen, which is real-time pole min and max values. So here we can see man and min readings from this screen. VAN, VBN, These are maximum values over the period that, over a certain period that the file was created for. So we have volts, AN, VBN, VCN, and phase-to-phase voltage, average demand, maximum three-phase watts demand. So that's the peak value that occurred during this period. There's a date and time associated with that, and the time. There are all the other information that you can see with this: frequency, quadrant, individual quadrant. So you get a large amount of information. If I just expand this further, this almost seems like it goes on indefinitely. But it's just a large volume of data that you get with this min and max screen. So I think we're going to limit this part of the discussion to just these two for now, and we're going to take a look at the revenue and energy. Revenue and energy screen. So the revenue and energy screen, we can take a look at the power and demand average, I should say power, demand, and energy screen. So what we're looking at is, again, a lot of the same information, but broken down different ways. The total VA is reported here, total watts, total VARs. So if you were looking for power factor on one of your polling screens, you will find it here. You'll see a min and max values reported here as well. Also on this screen, we actually see what's on the registers of being, if you want to take a screenshot of what the energy readings or register readings on the display of the meter, you would go to this screen. And this is one screen that you can look at to get that information. It also provides the demand window. This is set for block demand. That means energy stored in 15-minute blocks. This is 15 minutes, as opposed to rolling demand. Those are the two formats for demand, rolling and block. And depending on what your perspective or who you are, utilities like to use rolling demand as a selection, and some other customers might want to use block. So it varies on your choices. But this is what screen that you will get from the power, demand, and energy screen. So let's go continue here with the demand. So this is the demand or average demand screen, and this is basically breaking down again with the quadrants 1 and 4 for delivered watts, or 2 and 3 for received watts, quadrants 1 and 2 for VARs delivered, and quadrants 3 and 4 for VARs received, and your total VA. Again, this is the average information for that period, and it's shown in the screen. So we'll look at what we call the demand grid, and the demand grid shows a lot of the information. This is interval end at 4:23 up until 4:30. So this is showing all the data posted up until that time. And again, it's similar to what we saw before, but it would be more current than what you saw in the previous screen. Then you will find the energy grid. So here you find, as we saw previously, energy readings on the display. So these are, if the meter was programmed for compensation, or we were compensating for line losses or transmission line losses or things like that, you will see the uncompensated value here, and then the compensated. In this particular case, they're pretty much identical, so it tells me that meter was not adjusted for compensation. This column here is called the energy in the interval, the amount of energy that's stored. It's telling you that's what the amount of energy that's stored per interval. So if a meter is 15 intervals, that's 4 intervals per hour. and this value, this would be 4 times that value. And that's, if I looked at 1035 and went back and took a look at multiplied at times 4, I would see approximately 4 megawatts in the polling. So it's about 4 megawatts there. But basically, the energy grid is just another way of viewing, making sure you have all your energy values. Energy in interval pulses is another way of the meter recording pulses internally. It has an internal recorder where it stores this information, and you'll see it recorded in pulse value, not in an energy value. So everything here pretty much replicates, I should say, similar information that we saw previously, except these are all energy values. These are not instantaneous values. It's this energy for a interval period. So time of use is where we are now. So time of use gives us the ability to set up the meter for time of use, or we call it time of demand, or TOD, or there are lots of different ways, names or terminology that people use, but basically these are primarily set up for customers that use or are involved or signed up for this program, usually with a utility, where they would get a certain rate based on the time of their consumption. And so this allows the meter to capture that information. So here it's typically set up by seasons, prior billing information, current seasons, and so on. So this is stored in the meter, and the meter would automatically save the information for retrieval at some point. If you look at the status, this is an area where if we're talking about once we set those up, we can see the various seasons that we're looking for. If you're looking for billing period information, self-read status typically means that the meter does what we call an automatic reset. If you set the frequency of how you want it to reset, it will do an automatic reset. For instance, if you wanted to reset once a month at midnight, at the end of the month you wanted to bill a customer, you would set this up for self-read at the end of the month, and that is tied to a calendar in the system where you would set your date and time for that period, and the meter would execute the reset. So pulse accumulators. Pulse accumulators are, in this particular case, we see there's an option board that the meter has the ability to take in pulse, also ability to put out pulses. And so if we had a module or anything, additional device that we added on, this would be a card, an option card. We would install it, and we could take in pulses from a water meter or gas meter, and it would be accumulated into these registers. So that's what the pulse accumulators are. And you would label the quantity that you're bringing in. If it's a water meter on the west side of a building, you can name it such with a name similar related to something like that. But yeah, so this is the option board that brings in all the pulse data externally. And again, this is something that you would purchase separately and add it and install in the meter. It's just a card that's installed, and it's a slot, and the meter has 2 slots available. And so currently this particular meter has an Ethernet board, and you have one other option, and we saw that when we first connected. It looks like a KYZ board. So those are the options. Next, we have the pulse aggregators, and this meter has the ability to aggregate internally different quantities that you want from different sources. So if you're aggregating energy, you want to totalize energy from 2 different sources onto one channel, the meter allows you to do that. There are 4 options or 4 aggregators you can build. and you can generate reports and view that information as it was one quantity. So again, it aggregates all the individual input points and it allows you to view that information.